Hello everyone. So now we have section 12.6. So in 12.6 we have many objectives. Objective 1 is simplify a logarithmic expression by applying a property of logarithms. Properties of logarithms. If b, m, and n are positive numbers and b not equal to 1, then log 1 equals 0 for any base, because so here we start from the base, so the base is b, so b to the power 0 is equal to 1, so b to the power 0, it is clear that any number to a power 0 equal 1. Log with base b, b to the power x equal x, because b to the power x equal b to the power x. Log with base b of b equal 1, because b to the power 1 equal b. For b to the power log with base b of x equal x. So to prove this, look, we know that log x with base b equal log x with base b, so these two are equal. Now use the definition of logarithm, so we start from the base, so the base here is b, so b to the power log with base b of x, so b to the power log with base b of x is equal to x, which is the same like this. Or b is cancelled with b, so here b is the same, b is cancelled with b, so x, we get x. 5. Log the product, m times n, is the sum of the logs. So if we have the product m times n, so this is equal to log m with base, the same base here is b, plus log n with the same base. So log the product equal the sum of the logs. Log the quotient, log m over n, is the difference of the logs, so equal log m minus log n with the same base. So if the base is b, so we put b. 7. Log of a power, so we have m to the power p is equal the power times the log. So log m to the power p equal p times log m with the same base, b. If log x with base b equal log y with base b, then x equal to y. This is always correct. Fill in the blanks. Log 7 with base 7 equal to 1, because 7 to the power 1 equals 7. Or use property 3, log b with base b equal to 1. Log 4, 4 to the power 3. So here we use which property? Property 2. Log b to the power x with base b is equal to x. So here b is 4. And x is 3. So log 4 to the power 3 with base 4 is equal to 3, or 4 is cancelled with 4, we get 3. Log 1 for any base equals 0 by property 1. Now 7 to the power log with base 7 of 9 equal to 9. Use property 4. That's a property. So here b is 7 and x is 9 by property 4. Or 7 is cancelled with 7, so we get 9. Objective 2. Expand a logarithmic expression. So here we have single log. We will expand into the sum or difference of logs. So here log x cubed times y to the power 1/2. So log the product equal the sum of the logs. So we can rewrite it like log x cubed plus log y to the power 1/2 with the same base b. Now log x cubed, log the power equal the power times log. So we can bring 3 at the front of the log. So this is equal to 3 log x. Also here similarly, log the power equal the power times log. So this is equal to 1/2 log y with the same base. Objective 3. Write a logarithmic expression as a single logarithm. So here we will use the properties of logarithms to combine several logarithms into one logarithm. So if we have a 3 log x plus 1 minus 2 log x plus 2 plus log x with the same base b. So here 3 times log, this 3 is the power for x plus 1. So we can rewrite it like log the power. Minus 2, this 2 is also the power for x plus 2. We can rewrite it like log x plus 2 square plus log x. Now the difference of 2 log is log the quotient. We can rewrite it like log x plus 1 cube over x plus 2 square plus log x. Now the sum of 2 log is log the product. So we can rewrite it like this, log x plus 1 cube over x plus 2 square times x. So now we have single log. So we use the properties of logarithms to combine several logarithms into one log. Objective 4. Evaluate a logarithm by applying properties of logarithms. Example. Assume that log 4 equal 60/100. So this is given. So log 4 approximately equal to 60/100. Log 7 is given also. Log 9 is approximately equal to 95/100. Use these values and the properties of logarithms to approximate the value. Log 324 over 63. Now 324 is 9 times 36, and 63 is 9 times 7. So divide out by 9, so we get log 36 over 7. Now, log the quotient, we can rewrite it as the difference of 2 log. This is equal to log 36 minus log 7. 36 is 4 times 9. Now, log the product 4 times 9 is the sum of two logs, so log 4 times log 9. Then keep log 7 minus log 7. Now substitute. Log 4 is given, which is equal to 60/100. Log 9 is given, and log 7 is also given, which is equal to 85/100. So simplify. So this is equal to 0.70. Now, section 12.7 on page 95. Common logarithms, natural logarithms, and change of base. Now, we know that if the logarithm like this, log x, if the base is not indicated, so this means that the base we can put like 10. The base is 10. This is called common logarithm. So if the base is not indicated, this means that the base is 10. This log is called common logarithm. Now, new in this section is ln x. Now, if the base for the log is e, natural logarithm, and e here is equal to approximately equal to 2.7. So if the base for the logarithm is e, this log is called natural logarithm, and we denote it by this symbol ln, ln. So ln means natural logarithm. So the base here is e, and e is approximately equal to 2.7. Example, find each logarithm if possible. Express your answer to 4 decimal places. Find ln 0.523. So here use the calculator to find ln. Use the calculator to find ln 0.523, so which is equal approximately to negative 0.6482. Try to find ln from calculator. Another example, ln 0.00725. Also use the calculator to find ln, this number. So it is equal or approximately equal to negative 4.9268. Find ln x. So if ln x equal 1.548, find x. So we know that the base for ln is e. So to solve this equation or to find x, so first convert this natural log into exponential function. So this logarithmic function is equivalent to, so start from the base. The base here is e. So e to the power 1.548 is equal to x. So now we have exponential function. To find x, use a scientific calculator to find x. So first enter these numbers 1.548 and press these keys. So enter 1.548, then press this key, which is e to the power x. You will find x approximately equal to 4.7021. So to find the value for this number from calculator, use the key e to the power x, e to the power x. So first type these numbers 1.548, then the key e to the power x. So you will get x equal 4.7021. Apply the change of base formula. Sometimes if you have like this log, you cannot find the value for this log from calculator. The calculator finds logarithm with base 10 or with base e, which is natural logarithm len. So if the base is different than 10 or e, you cannot find it. So we will try to change the base. So here we use apply the change of base formula. If a, b, and x are real numbers, b greater than 0 and b not equal to 1, then log with base b of x, this log is equivalent to log x over log b. Then we can put any base. You can put a or 10 or e for a new base a. Also, log with base b of x. So if we put e for the base, so we get natural logarithm or len x over len b. So here we put a new base, which is e here. So if the base is e, the log becomes natural logarithm. So now let us find log with base 1/2 of 6. So now use the change of base. So this is equal to log 6 over log 1/2 or 0.5. Then we put a new base, which is 10. Now log with base 10 of 6, we can find this from calculator. Use the calculator to find log 6, which is equal to 0.7782. Also use the calculator to find log 0.5, which is equal to negative 0.3010. So now divide. So the answer is equal to negative 2.5854. So the change of base formula is helpful when calculating logarithms of bases other than common logarithms and natural logarithms. The last section here we have 12(8) exponential and logarithmic equation and the problem solving. Now to solve an exponential and logarithmic equation, apply the following procedure. 1. If there is a variable in the exponent's position, so for example like this. So here we have this example, 7 to the power x squared plus 3x. So here we have variable in the exponent. So try to convert both sides of the equation to the same base and then use the fact if b to the power x equal b to the power y, then x equal to y. So now try to make the same base. So now 1 over 49, we can rewrite it 1 over 7 squared. 1 over 7 squared equals 7 to the negative 2. So now we have the same base. We have the same base. Now use this fact. If b to the power x equal b to the power y, then x equal to y. So here the base is the same. Therefore, the exponent should be equal. So x squared plus 3x equal to negative 2. So now solve this equation. So add 2 to both sides. So we get x squared plus 3x plus 2 equals 0. Factor this by Schrödinger and error. So here, x squared is x times x. Look at the sign for the last term. If the sign for the last term is positive, so the sign for the binomial is the same like middle. So 2 is 2 times 1. Let us check. The inner product is 2x. The outer product is 1x. So 2x plus 1x equals 3x, which is the middle. So x plus 2 equals 0. Then x equals negative 2. Or x plus 1 equals 0, so x equals negative 1. So this is the solution. X equals negative 2 or negative 1. You can check. Just substitute negative 2 or negative 1 in the original equation, so you will get left hand side equal right hand side. Now, there is another method. If there is a variable in the exponent position, like this. So here also the variable is the exponent. But we cannot rewrite it like this, the same base. So here 12, we cannot rewrite it 12 like 7 to the power something. So here we take the log of both sides of the equation and solve for the variable. So now take log for both sides. So we get log 7 to the power x equal log 12. Now log 7 to the power x, so log the power equal the power times log. So we can bring x into the front of the log. So this is equal to x times log 7 equal log 12. Log 12 or log 7, this is numbers. We can find these two logs from calculator. So first, divide both sides of these two of the equation by log 7. Divide by log 7. So we get x equal log 12 over log 7. Now use the calculator to find log 12 and log 7. So log 12 with base 10 is equal 1.0792. Log 7 with base 10 equal 0.8451. So divide, so we get 1.2770. 2. If the variable appears inside a logarithm, so for example like this, so here the variable appears inside the logarithm, simplify a single logarithm and convert the problem to an exponential equation. So simplify to a single logarithm. So try to make the sum of these two log as a single log. So use the properties of logarithms. So here there is hint, convert to a single log, equal a number, then convert to exponential equation. Now the sum of two log, this is log the product. So this is equal to log x times x plus 3 equal 1. So here the base is not indicated, this means the base is 10. So convert this logarithmic equation to exponential, which is equal to 10 to the power 1 equal x times x plus 3. So 10 to the power 1 equal x times x plus 3. Solve this equation. So use the distributive property. X times x is x squared. X times 3 is 3x. Subtract 10. So we get 0 equal x squared plus 3x minus 10. Factor this by trial and error. So x squared is x times x. If the sign for the last term is negative, so the sign for the binomial is one positive, the other is negative. So 10 is 5 times 2. Let us check. The inner product is 5x. The outer product is negative 2. So 5x minus 2x equal 3x, which is the middle term. So now by zero factor property, x plus 5 equals 0 or x minus 2 equals 0. So x plus 5 equals 0, then x equals negative 5. So we reject the solution. Why? Because if we substitute negative 5 for x in the original equation, so we get log of negative 5. Log for negative numbers is undefined. Log for 0 is also undefined. So the log is defined just for positive numbers. That's why we reject this number. Or x minus 2 equals 0, so x equals 2. So now the solution is x equals 2. You can check if you substitute 2 for x in the original equation, so you will get left hand side equal to right hand side. So if you substitute here 2 for x, so we get log 2 plus log 2 plus 3 is 5. So log 2 plus log 5 is log 2 times 5, log the product. And log 2 times 5 is log 10. So here we can write it like this. Log 2 plus log 2 plus 3. Is it equal to 1? Or log 2 plus log 2 plus 3 is 5. Is it equal to 1? This is check. Now the sum of 2 log, this is log the product, 2 times 5. Is it equal to 1? 2 times 5 is 10. Is it equal to 1? So here the base is not indicated. This means that the base is 10. So now log 10 with base 10 equal 1? Yes. So because 10 to the power 1 equal 10. So 1 is equal to 1. This is true statement. So the solution is x equal, the solution is x equal 2. Thank you.